Hey, and welcome back. So today we're going to talk about a little bit about something that I've been working on and get into the technology. I had a lot of problems with this. I kind of feel a little bit stupid because I did, but hey, so I just wanted to go over this. So I was working on a real-time audio analysis project, and this is from calling. So it's from voice technology. And as part of that, I am using a company called Signalwire. So let's just jump over and let me get into that documentation. So this is Signalwire, and what we're looking at is called the tap action. So why I'm using Signalwire is because Signalwire uses something called relay, which is an open connection for VoIP. This is super handy because you can maintain the connection open. It's like opening a socket between two endpoints and send the commands through. And this is cool because it's faster than using the callback like Twilio's algorithm that's using a lot of callbacks, which has a delay. You know, you need to initialize the callback, execute the callback, respond to the callback. Where here it's an active open socket, so you're saving quite a few microseconds in every process in handling the communication. So the objective here was to analyze the audio stream that coming through. So here we come to what we see is relay action tap. So the action tap is an open stream of information. This is their help documentation. And you'll notice it's an RTP. So this threw me a lot because reading on the online we normally have a socket connection or a SIP connection or some other type of controlling protocol that sits on top. But here, as I discovered, when it talks about RTP, we're talking about a raw package manager. So actually trying to get this work out, it just kind of threw me. I wasn't expecting uh, anything like that. That it was just a raw package manager. Um, and since then, SignalWire said they're implementing a WebSocket version, so we can handle JSON packages and the streams coming through JSON packages, which would make things a lot easier. But this was a challenge because I didn't see much about RTP. So I thought I'd go into a little bit of the code about how we solve that. So here I went through quite a few packages because I had quite a few issues coming through. Um, but we'll go down to the main code. I've just hidden this local endpoint. So what I decided to do was create a sync IO loop, and we're using the datagram endpoint. So we're going to listen to the raw UDP package port. So here I'm binding, the IP. This is not the real IP to a port. So I just choose an 8888. So you'll notice in this protocol, there's no handshake, there's no security. It's just pushing the data to a raw port. So here we're going to run it forever. So the next part of the RDP, which kind of threw me, was how it's set up. So we have a few. I ended up using Scapy for decoding the RDP in the end and breaking it down into its individual field. So let's have a look at that. So as a package comes through, we're seeing the version number, padding, extension, CSI count, so apparently that's the version here, and then we break it down into the marker, which is not a sequence number, timestamp, and then eventually into the payload itself. So this was complexity 1. So as the data is coming in, I receive the packet. Each packet I have to divide it into its individual components, and then from its individual components reading the data, and here there is apparently a buffer issue, hence the 0 here. Um, and here we append the data, so it's increasing the data stream. So this is basically a binary, and you're increasing the bytes here for that binary. Lots of stub code. And just for a test, I use this wave writer. So the wave I'm using pi wave to write it. So we've created the wave file, and this RTP package is sending in a compression. So the compression here of audio is, so the SIP compression here is PCMU in this algorithm. So in the code we have our wave write and we have our compression and our other arguments here. So we can won't go into more than this. So the number of channels, I set it to 1. Sample rate, because we're doing analytics, we don't want to go overboard. 800, 8 bits per second, and the compression to be PCMU. And that's what we can see here set up. So as we write that, so one of the issues was, working out how to read that. So as I said, I'm using pi wave to read it. One of the biggest things to be wary of this package is that its write only writes once, it doesn't append. Hence why I've got this random number just to test out to see how it writes. So this is very cool. Once it kind of started working, we can send and receive these packages as raw RTP here, and also we should be able to communicate with it. But the purpose here was a real-time analyst. So I won't get into that right now about using this stream to analyze things such as text-to-speech as the data comes through, understanding end of a sentence when it goes quiet, and other algorithms. So sentiment analysis on audio rather than sentiment analysis on text. So this is why this was very important to get up and running. Many choices out there, a bit tricky to get started with, but once you kind of get going and you understand what you're looking for, this was it's pretty cool protocol and pretty cool way to kind of bind directly to those ports and read any data that's coming through.